Founded in 1939, EIKEN Chemical has been remained as a leading company in vitro diagnostic reagents in Japan for many years. Beginning with the first generation OC sensor in 1989, various devices and the OC sensor series brand have been developed. Fecal cut blood test is firmly positioned at the first step in the early detection of colorectal cancer. With its features of easy to perform, huge quantity of processing capacity, excellent cost performance, and proven effective in reduction of mortality rate, fecal cut blood test has been established as the most optimized screening method previous to a cost-thorough examination. Two measurement principles are used for fecal occult blood test: chemical and immunochemical, in guidelines and also the guidelines for colorectal cancer screening issued by European Commission in 2010. The immunochemical quantitative FOBT was recommended and is used for screening of citizens in many countries. The chemical method used in the past had a number of disadvantages, including many non-specific reactions, need for dietary restrictions days previous to the test, and odor occurs. FIT, fecal immunochemical test, has been widely used by no restrictions on diet or medications are required. High sensitivity and specificity with its specific reaction with human hemoglobin. Odorless due to the samples taken and sealed by sampling bottles. There are two methods in fecal cut blood test: method of visual judgment and method that uses an analyzer. Analyzer has several advantages over visual judgment. First of all, automated analyzer could provide data. Secondly, barcode system management could be realized by a fast, labor-saving system. Thirdly, a quantitative result could tell the level of hemoglobin in feces. Furthermore, it is also possible to set the optimal cutoff value based on national and regional studies. Lastly, accuracy management can also be established. OC sensor by EIKEN Chemical utilizes an immunochemical method using lattice aggregation immunoturbidimetry, has eliminated the disadvantages of chemical method and improving testing efficiency and accuracy. OC sensor is based on the principles of lattice aggregation immunoturbidimetry. One sample mixed with a lattice reagent in which anti-human hemoglobin antibodies are sensitized to the evening-sized polystyrene lattice particles. The anti-human hemoglobin antibodies sensitized to latex react with the hemoglobin in the sample. Antigen-antibody reaction and aggregation occurs. The analyzer measures the change in absorbance by shining a 660 nanometer LED beam through the agglomerate. If no hemoglobin antigens in the sample, no aggregation occurs, and the light passes easily through the sample. Conversely, when hemoglobin antigen exists, The light cannot easily pass through the sample due to the increase in turbidity. Absorbance increases. Amount of the absorbance change increases in proportion to the concentration of hemoglobin in the sample. The analyzer applies the absorbance change to a calibration curve and calculates the hemoglobin concentration in the sample automatically. Sampling bottle, especially used for OC sensor, also has a number of unique characteristics. Easy to hold, easy to use, sophisticatedly designed. Easily opened by just twisting the cap and closed insecurely by snapping it shut. No other escape from the bottle. The flat surface of the sampling bottles allows an easy writing on the label, and the expiration date can be easily viewed. The barcode on the sampling bottle can be read by the analyzer equipped with a barcode reader. Any excess amount of stool on the groove is scraped off as the sample stick is inserted through the scraper, allowing an accurate 10 mg sampling. The top of the sampling cup and the filter are double covered by aluminum stickers to prevent bottle damage and leakage. The use of squeeze-up filtering method prevents any residual stool from affecting the reaction. The filtered samples goes into the sampling cup when squeezed by the instrument, is sampled into the reaction cuvette. The remaining sample flows back into the sampling bottle. The innovative sampling bottle is highly hygienic, completely odor-free, easy to use, and improves accuracy. The special OC sensor sampling bottle is a completely new FOBT tool that connects the patients and the physicians. Here we would go with the actual sampling procedure. Collection paper enables patients to take samples without taking stools out of the toilet. To use the collection paper, all you have to do is put it in the toilet bowl. It is very hygienic, preventing contamination of the patient's hands and the surroundings area. Patients only have to put the collection paper inside the toilet bowl before a bowel movement, and then sample the stool. The paper can be flushed away after sampling, and the disposal is easy. Write your name on the label. Twist the cap and withdraw sampling stick. Scrape all over the surface of a stool. The appropriate amount of stool is just enough to fill the grooves on the tip. Insert it in the sampling bottle until it snaps in place. Do not pull it out once it is inserted. Simply submit the sample to a physician or a nursing staff. Here we go to the OC sensor EO analyzer. EO is a sleekly styled automated analyzer. Besides of sleek design, EO was developed in pursuit of high accuracy for producing high-quality measurement result, easy operation that allows the analyzer to be used safely by anyone, small size with full automation and a range of precise functions, and other features all contained in the sophisticated design. A broad range of smart solutions, need for automation and quantification of expanding FOBT manual to automated analysis will be provided continuously. Next, let's look at the features of components that makes possible to achieve the concept. EU is a sleekly styled automated analyzer that requires little space. 3 easy observable LED lamps clearly indicate the operation process and whether the door can be opened. Samples and cuvettes can be added while measurement is in progress, which causes no lost waiting time. Equipped with a high processing capacity, it can satisfy the needs of many facilities. All operations can be performed from a 5.7-inch color LCD touch panel, allows an easy confirmation on process and remaining amounts of reagents. With the function of cutoff value flexibly changed, this controls the positive rate and be able to meet a wide range of needs. With the Pro Zone Check function, PRC method is used to identify high concentration samples. A full range of external interfaces is provided, including USB port, LAN, and RS-232C. The operating procedure. For measurement, purified water, wash solution, buffer, and latex reagent are needed. Before starting measurement, be sure that all of them are sufficient. First, enter the reagent bottle lot number and install the latest reagent in the reagent holder. The bottle is stored at 25 degrees, and 1 bottle is enough for measurement of approximately 100 samples. Install 2 sets of 10 linked disposable reaction cuvette. This is the required amount for 20 samples and stored at 37 degrees. Install the rack containing the sampling bottles onto the sample holder. A maximum of 20 samples can be installed. Measurement is possible even when bottles and cups are mixed in the same rack. Press the Start button on the LCD touch panel to start the measurement. Now let's have a look at the flow of measurement. When the samples are installed and the Start button is pressed, the number of samples is detected. The bottle or cup sensor counts the number of samples and recognizes automatically sampling bottle or sampling cup. Sampling bottle with a barcode supported by the system, the barcode label is being read at the same time. The puncture needle penetrates the 2 aluminum stickers on sampling bottle. The squeeze arms press the sampling bottle from both of the left and the right sides. The sample solution goes through the filter into the sampling cup at the top. This sample is sampled by the nozzle and is dispensed into the reaction cuvette. After sampling, any excess sample flows back into the sampling bottle. After the sampling nozzle is finished dispensing, wash solution is injected to wash the inside of the nozzle. Then purified water is used to clean the entire nozzle. When all sample dispensing is completed, the latex reagent is dispensed into the reaction cuvettes. The high-speed mixer nozzle mixes the sample and reagent mixer into the cuvette. After mixing, the mixer nozzle is washed in the washing tank. The internal photometry unit measures the change in absorbance over time and calculates a numerical result from the calibration curve. The first result is printed out in approximately 7 minutes. The measurement results are indicated as a measured concentration and a positive and negative result based on the cutoff value. OC sensor EO, with its wide range of functions concealed in a sophisticated design, provides simple, user-friendly operation to bring a revolution in speed and simplicity to your measurement environment. With its compact size, large quantity capacity of functions, OC sensor EO could be confidently recommended to meet all screening requirements all over the world.